Good afternoon, everyone. My name is Ashish. Shah. I'm a Director of Product Management at Avi Networks, and welcome to the session on lessons learned and best practices in OpenStack LBAS deployment. All of us are here at the OpenStack Summit, and we'll see more and more production deployments of OpenStack, especially in the enterprises. We heard Volkswagen yesterday. We had Walmart's been using Avi, using OpenStack, Time Warner Cable, EBSCO, and many others, right? So we're seeing a lot more deployments of OpenStack in production environment. However, what we learned from our customers is that there is still there are still issues with performance, security, network services such as load balancing, application monitoring in OpenStack. So in this session, we're going to talk about what those issues are and what are the best practices based on the customers who've deployed load balancing. What are the best practices that you can deploy right away? So why is performance, scalability, security so hard? Why is load balancing as a function so hard in OpenStack today? Well, you have a choice between an open source solution on one end. You have HA proxy that almost all of you get started with, right? Because that's integrated. Well, that's right. It's easy to start with, but it doesn't have all the enterprise-grade features. You are used to deploying traditional load balancers with all the bells and whistles. You want to do content switching. You want to do advanced policies. Your HA proxy doesn't come with that. It also doesn't give you the elastic scale, the automation, the analytics that you need for your production deployment. On the other hand, you're used to your legacy appliances, whether hardware appliances or software appliances. They have all the bells and whistles, all the features that you're used to, that you deployed today in your data center that you want to move to OpenStack. However, the problem there is that it's not easy to integrate and automate. We know from our customers, and you can probably attest to that, it's extremely difficult to automate your virtual appliances or hardware appliances, right? You don't get the cloud-like feeling. So what you need is the bridge between the open source solutions, which are already integrated, easy to deal with the full-featured enterprise-grade load balancer that you're used to, right? So that's where the best practices come in. That's where even Avi Networks comes in, and we'll talk about that in just a minute. But what's required is a solution that mirrors the capabilities of your dynamic cloud, whether it's OpenStack or even a hybrid cloud with, you might have vSphere, you might have AWS, you might have containers. You need a solution that runs in software. It runs on x86, that runs in bare metal, runs in VM, runs in containers, runs in public cloud, right? You need a solution that offers a self-service and programmability that you can do for compute and storage and rest of the network in your OpenStack. You want to do that for load balancers as well. You want multi-tenancy that's tied to Keystone, right? Because if you want to deploy in a self-service multi-tenant environment, you don't want to define other sort of tenants or deploy appliances that are for one tenant or separately from the other tenant. And you want the automation that's built in. As you deploy applications, you want to deploy load balancers as part of a CI/CD deployment. Combine this software-defined principles with the enterprise-grade features. So think beyond load balancing. Of course, you need layer 7 load balancing. Of course, you need advanced policies. Of course, you need SSL termination. But you also need visibility and analytics. You need the AWS-like elasticity, horizontal scale, that when your application grows, your load balancer grows. You want to automate the whole infrastructure. That's what you need in your OpenStack deployment. So that's what our customers have done. That's what they're using with Avi. So before I go into the specific deployment models and multi-tenancy scenarios and self-service deployment, let me give you a quick update on what Avi Networks is. So Avi Networks has built a distributed load balancer with a centralized control plane. It's a web-scale application services fabric. So what we did was we took the appliance load balancers, we separated the control plane from data plane. So it's an SDN principle. You're probably used to L2, L3 SDN solutions, right? We applied the same principles to load balancers. And we said, we centralized the control plane, and we distributed the data plane across your compute infrastructure. So these data planes, we call them service engines. They can run as bare metal. They can run as virtual machines. They can even run on a container environment and simultaneously in public cloud. All of these are centrally managed by Avi Controller. Avi Controller becomes your single point of management, control, and integration. It's 100% REST API, which means you're configuring a whip. You go to the Avi Controller and provision the whip. Avi Controller automatically spins up these load balancers on demand, places intelligently close to the workload, downloads the policy, and starts receiving traffic. You don't have to worry about spinning up a VM. You don't have to worry about connecting the right VLAN. You don't have to worry about does it have enough capacity or not. The entire life cycle is completely automated. Now, in addition to load balancing itself, as I said earlier, these data plane service engines are also collecting hundreds of logs and metrics every second. These are pushed up to the AVI controller, which presents a nice dashboard. We'll see some of the screenshots here as well. And so this analytics engine that runs on AVI controller gives you actionable insights into what's going on. It's no longer a black box. It tells you whether there are any performance issues. It tells you where the traffic is coming from. And it actually uses this analytics information to automatically make policy changes into your infrastructure. So for example, as the traffic grows and the number of application instances that you're load balancing are limited, let's say latency increases, we can automatically scale out your application infrastructure based on the policies. So not only it's not static, it's dynamic in terms of scaling out application instances, but it can also scale out load balancers on demand. So it's a fully automatically scalable enterprise-grade load balancer. And it's a drop-in replacement for HA proxy. Let's look at that, right? So how does it work in case of OpenStack? And how our customers, such as Time Warner Cable, EBSCO, and many others, have deployed this in a production OpenStack deployment? So what you do at first, day one, is you deploy the AVI controller. AVI controller is a cluster of 3 VMs. They are Nova instances. They're actually running on OpenStack. They are not appliances outside. They're actually compute instances in Nova. You point it to the OpenStack services. And once you do that, it talks to Keystone and imports all tenants, roles, and users. So now the same tenants are represented in AVI. Then you can have 2 ways to configure your VIPs. You can use the LBAS. AVI has an LBAS plugin to which you configure a load balancer. Or you can use REST APIs, and our customers do both. They give a combination of these. That talks directly to the AVI controller. Once you configure a WIP, what the AVI controller is going to do is it's going to talk to Nova and spin up these service engines or load balancers in the right tenant. You can have load balancer spun up directly in the context of the tenant, a specific project. Or you can have load balancer shared across multiple projects, your choice, right? It spins up the load balancers on demand, then it talks to Neutron and plumbs them into the right network. Whether you're using SDN or not, it doesn't matter. We talk to Neutron and make sure these load balancers are correctly plumbed into the right network automatically. And then it downloads the policy, and now you start receiving traffic. In addition to that, though, we have integrated analytics right into Horizon. So as the traffic is passing through the load balancer, you can actually see what's going on. I'll see you in the next slide. So again, what the customers are doing is they want a solution that is natively integrated with OpenStack, not an appliance that sits outside and you have to manually manage those life cycles. If you have a failure, let's say you need HA. So I'm showing you 3 different tenants with 3 different HA models. The tenant 1 has active HA, which gets a platinum tenant. So if one of the load balancer fails, well, the other one's already there to take up the traffic, and in a few seconds, AVI control will spin up another Nova instance. The second tenant, it's a lower level SLA, pays less, you can do chargebacks, and it has an active standby HA. The third tenant has a best effort HA. What does that mean? If the load balancer fails, in a minute we'll spin up another one. Until then, there is a disruption. So you can have dev, test, production tenants doing different things, right? But what this allows you to have is a centralized controller with policy management and have a true multi-tenant scenario that's natively integrated with Keystone. Let's look at some of the integration that we have done with Horizon and some of the analytics capabilities that's on top of the load balancer. So in this case, what you see is in Horizon itself, in the Horizon dashboard itself, we have integrated our analytics dashboard. So you can see what the individual traffic latencies are or what the logs are. For example, you can see the application map of how different applications are talking to each other, what the latencies are. It's dynamically built application map. You can see individual transactions. So for example, this transaction is coming from France with somebody running on a computer on a Firefox browser with Windows machine, Windows operating system. It took 135 milliseconds over the WAN to hit the load balancer. It took 1 millisecond in the data center network to hit the server. The server took 150 milliseconds to process the request, and it took 1 millisecond for the data to go back. This is your troubleshooting tool. Our customers call it mean time to innocence tool because there is no more finger pointing if there's a problem. It tells you network, server, application, bandwidth, where the problem might be. You can search for logs saying, show me only the logs coming from iPhone from the US. So that's the right-hand side screen where it says, what are the logs at what different times they have come from and so on, right? Built into Horizon. You can get SSL insights. So for example, what are the different SSL versions the customers are using? What type of certificates they are using? If there is any security that's weak or misconfigured ciphers, for example, we call out in terms of a security score. Or if you're going through a DDoS attack, that's called out right into Horizon, right? So this is more than a load balancer. It's an enterprise-grade load balancer integrated with analytics engine. Here is how one of our customers is using it. So you'll see a nice division of labor in terms of the cloud admin, which is shown at the top. They're using Avi UI to talk to Avi controller to specify policies. Says tenant 1 can have this level of SLA for load balancers. They can use this flavor of Nova instance. For example, this vCPU, this many vCPUs, and this many memory. And a tenant 2 can have a different policy. So it's controlled by the IT admin. And then individual lines of businesses, the users, log into Horizon using the Keystone credentials and spin up their applications and their load balancers without opening up a ticket. Completely self-service, multi-tenant solution. And what you get is a full-featured load balancer. That's a distributed load balancer with a centralized monitoring and management and policy engine that is natively integrated with the OpenStack services. That's what you need so that you have the automation that's built in. You have 100% REST API, so you can automate the entire application deployment, not just load balancer deployment. And you get self-service multi-tenancy and auto-scale. All right? So these are some of the best practices that we have learned from our customers and implemented in our product. And again, if you want to have more information on that, we are in booth C24. You can actually download this from our website as well. It's free for development use. It's full-featured. Go to avinetworks.com/try. Download it in your OpenStack environment, in your legacy environment, in your public cloud environment, and have fun. Thank you.